In this video, I'm going to go over another type of hydrocarbon. These are known as the cyclic hydrocarbons. I mentioned this earlier. So carbon-carbon bonding is common. Well, if this bonding leads to the formation of what's known as a ring structure, they're known as cyclic hydrocarbons. So let's have a look at these. Just in terms of some things you need to remember for naming cyclic hydrocarbons. So molecules that have carbon-carbon bonding, but the longest continuous chain forms a ring. So that's important. What you're now looking for is if the longest continuous chain is part of a ring structure, that dictates it's now a cyclic hydrocarbon. These rings can be branch-free or can contain alkyl branches, and as we'll learn later, could actually have other substituted functional groups. The ring component is dealt with by adding the prefix cyclo to an alkane name. That's really the only difference. So that's shown here by example. So cyclohexane, 6-carbon ring structure. That's what makes it a cyclic hydrocarbon. It's a ring structure, and because it's 6 carbons, it's a hexane, so cyclohexane. Any branches are dealt with by numbering accordingly if necessary, and naming and alphabetization. All that stuff we've looked at previously. So I think you'll find cyclic hydrocarbons is pretty straightforward because you already have the background. So let's have a look at some. So again, naming a regular hydrocarbon with the prefix cyclo in front, and then any alkyl branches dealt with as alkyl branches. So here's our first example. So there's the cyclic hydrocarbon ring structure. I would count these carbons. Remember, this is a line structural diagram. I count those carbons, so it's 6, so that is cyclohexane. In the second example, I have the longest continuous chain being this ring. I'm going to start numbering from where a branch is, because that minimizes the position of the branch. Here's my ring. It's 4 carbons long, so that's a cyclobutane. And on carbon 1, I have my methyl branch. Now, if this is the only branch, I don't need a number. So I can just call this methyl cyclobutane. And why don't I need a number? Because the branch is on a carbon. It's only this. It's only one single branch, and therefore it has to be on carbon 1. To minimize it, it has to be carbon 1. So the 1, in fact, becomes redundant. You don't really need it. If I had a second branch anywhere in there, I would require numbering. We see that here. So here's my ring. So I'm going to start numbering that, and that's a 5-carbon ring, so that's a cyclopentane. But now what I have is 2 methyl branches. They're both on carbon 1, but I have to number them because one of those branches could be on another carbon. So it's going to be 1, 1 dimethyl, because there's 2 methyl groups, both on carbon 1, cyclopentane. So now the numbering is required. Must number branches. As soon as you have more than one, you need to number. If there's only one, you don't need it because it'll always be carbon 1. Last example of drawing then. So again, another cyclopentane. What I have here is a methyl branch, and what I have here is an ethyl branch. So I can number a couple of ways, but I'm going to number this way: 1, 2, 3, 4, 5. And if I number this way, for one thing, I'm minimizing branches, and that puts the ethyl on carbon 1. And you have to order them alphabetically, so it's just a little more organized. So this is going to be 1 ethyl, 3 methyl. Remember, alkyl groups are alphabetized. Cyclopentane. Another answer that would be acceptable is if this was carbon 1. If you made the carbon with the methyl branch carbon 1, this would still be carbon 3 to minimize position. So you would alphabetize the branches, so it would be 3 ethyl, 1 methyl cyclopentane. That is also an acceptable name. Drawing cyclic hydrocarbons, then it's all in the name. So here we have where our branches are. We have 2 methyl branches on carbons 1 and carbon 3. It's cyclic. So it's a ring, and there's the length of our ring, butane, 4. So 1, 2, 3, 4. There's my cyclobutane ring. Carbon 1 is a methyl branch. Carbon 3 is a methyl branch. And I would attach hydrogens to satisfy the carbon bonding. And there's my diagram of 1,3-dimethyl cyclobutane. And finally, 3-methyl-1-propyl cyclohexane. So a cyclohexane is a 6-carbon ring. So 1 carbon, 2 carbon, 3, 4, 5, 6. Join the last one up. I'm going to put my I'm going to make this carbon 1, so that'll be a propyl branch. So 1 carbon, 2 carbon, 3 carbon. Line structure item, carbon 1, 2, 3. Now I could go 2, 3. It doesn't really matter. Let's go there. So there's my 3-methyl-1-propyl cyclohexane. So as you can see, cyclics is really not a lot different from alkanes. The cyclic component comes as a cyclo prefix, so that tells you it's a cyclic hydrocarbon. And obviously from a structure, as we've shown here, it's cyclic because of the ring. That's your longest continuous chain, hence making it hexane, and branches appear accordingly. Just to remind you, then, this British Chem Guide website goes through some naming conventions with the cyclic hydrocarbons as well, so you may want to have a look at that if you like. And that concludes this video.